In this module, we're going to learn how to declare identifiers. We're going to also learn about the 8 Java primitive types and learn the difference between primitive and reference types. So let's begin. In this module, we're going to discuss a wide range of topics. For example, we'll learn how to put comments in our source program. We'll also learn what the rules are for creating a valid identifier, as well as what the 8 Java primitive data types are. We'll learn the difference between a primitive variable and a reference variable, and how reference variables work with objects. We'll also learn how to create objects using the new operator, and we'll learn things such as passing arguments by value. In any programming, Java included, it's always a good idea to put comments in your code explaining what is going on. In Java, we have 3 styles of comments. The first is the single line comment, and we can see this in the upper left edit window. You begin the comment with // and then from that point on the line to the end of the line is a comment. So you can have an entire line as a comment using this, or you can begin the line with Java code and then put the / and your comment to document the end of the line. So once again, with this style of comment, the comment begins where the / is and runs to the end of the line. Now in the upper right hand edit window, we see a multi-line comment. This style of comment extends for several lines and begins with a /* and then ends when it encounters an */. This allows you to have a comment that extends over many lines. The final style of comment is the Java doc comment. Now this is similar to the multi-line comment, but begins with a /**, and then extends until it encounters an */. Now the Java doc comment is to be used with the Java doc utility. And the Java doc utility will read your source code looking for these styles of comments and then create HTML documentation based on these comments. Now along with these comments, you must also insert special keywords inside these comments that the Java doc utility will look for. Now the Java doc utility we will not be discussing in this class, so we will not be going over these special keywords. Now, unlike some other languages, Java is a free-form language. That means a line in the text file is not considered a line of code. What is considered a line of code is a statement, and that statement ends with a semicolon. And so Java does not look for the end of line character to tell it when to end a line. It looks for the semicolon. So here we have 2 examples illustrating this. We have totals equal A plus B plus C plus D plus E plus F, semicolon. The semicolon ends the statement. And then on lines 3 and 4, we see that a statement can run across multiple lines. So we have totals equals A plus B plus C on line 3, and then it continues on to line 4 with plus D plus E plus F, semicolon. So that ends the statement. Not the end of a line, but the semicolon. Now just like a statement can run across multiple lines in Java, now you could also have multiple statements on one line in the text file. For instance, you could have x equals 1 semicolon, y equals 2 semicolon. Now let's find out what a block is now that we know what a statement is and how it terminates with a semicolon. So click on the block tab. Now in Java, code is grouped into blocks. A block begins with a left curly brace and ends with a right curly brace. They must always match up. And lots of things are grouped in a block. For instance, our class definition is going to be in a block. An if statement will have a block of code associated with it. A for loop will have a block of code associated with it. So blocks group code, and they act sort of like a begin and an end with the left curly brace and the right curly brace. And also in this example, we see again how spacing doesn't matter. We have one block of code that extends over 4 lines, and then we have that same code block on 1 line. Again, Java doesn't look for end-of-line characters, it looks for semicolons to tell it when a statement has ended. So these 2 blocks of code are equivalent. So let's look at some block examples. Click the Block Examples tab. So here we see some of the places that you can use blocks. You could have a standalone block like we have at the top. A class definition must also be contained in a block. A while loop has a block that begins and ends it. And we can even nest blocks within other blocks, such as we have this if block nested within the while block. So you need to get used to the left and right curly braces acting as a begin and an end to a block, and make sure they always match up. In Java, we're going to name a lot of things. We're going to name our variables, we're going to name our methods, we're going to name our classes, our interfaces, etc. So we have to understand what the rules are for naming things. These names are called our identifiers. So let's look at these rules for identifiers. First, they must start with either an uppercase or lowercase letter, an underscore, or a $sign. Those are the only types of characters that you can use for the initial character. Then, after the initial character, you can use any of the characters we just mentioned plus numbers. No other types of characters are allowed, so you can't have question marks or pound signs or dashes or anything like that. Also, you cannot use a Java technology keyword as one of your identifiers. So we have a table of these that you can take a look at. For instance, you couldn't use the word false as one of your variable names because that is a reserved word. Now, those are the rules, and the compiler will give you an error message if you break any of those rules. The last 2 are naming conventions. They're just conventions that we follow, but if we break these, the compiler is not going to give us an error message. So, for instance, we begin our variable and method names with a lowercase letter. We'll begin our class names with an uppercase letter. These are just conventions, again, that most Java programmers follow. Also, typically, if your variable name or method name or class name has multiple words in them, we will capitalize the subsequent words in the name. So here we have an example called first name with a capital N for the second word in the variable name. In Java, most of the things that you're going to work with are objects. That's because Java is an object-oriented language. But there are 8 primitive data types that serve as the basic building blocks upon which we create our objects. These 8 primitive data types are byte, short, int, long, float, double, boolean, and char. Now the byte, short, int, and long data types are our integer data types. There are whole numbers. They contain no decimal places. Now the float and the double are our floating point data types, and they have a decimal place. The Boolean is a truth value. It either is true or false, and the char data type is a character data type. It can hold 1 character. Now the reason we have 4 integer data types is because they each take up a different amount of memory and can hold different value ranges. For instance, the byte is the smallest integer data type, and it takes up 1 byte of memory. But it can only hold values from -128 to +127. Now the short takes up 2 bytes of memory and can hold values from -32,000 approximately to +32,000. The int takes up 4 bytes of memory and can hold values from around -2 billion to +2 billion. And the long data type is the biggest integer data type, and it takes up 8 bytes of memory and can hold from around -9 quintillion to +9 quintillion, give or take a quintillion. Then for the floating point values, we have 2 of them, float and double. The float takes up 4 bytes of memory, and the double takes up 8 bytes of memory. And they can hold a wide range of values, as we can see from our chart. Lastly, the Boolean can hold values of false and true, as I mentioned before, and the char can hold a 16-bit Unicode value. Now, Unicode is similar to ASCII, but can hold a far greater range of characters. The ASCII character set is mostly the English character set of A, B, C, D, and 1, 2, 3, etc. Whereas the Unicode character set has characters from many different languages that English does not have. We also see in this chart how literal values are assigned to data type. Now, many people don't realize this, but in a program, when you see a literal value, such as the number 3, that gets associated a data type. So in Java, a 3, for instance, is assigned the int data type, whereas a 3 followed by an L, either capital or small, is given a long data type. So 3L is the literal for a long. If you want a literal float, you will specify it as, for instance, 3.0 with an F after it, either capital or small. If you just specify it as 3.0 without the F, it will be assigned the double data type. Now, there is another notation for the float and double, and that is the exponential notation. For instance, 3.0e to F. This is the same as 3.0 times 10 raised to the 2 power as a float. 3.0e2 would just be 3.0 times 10 raised to the 2 power as a double. And again, just like the F can be uppercase or lowercase, the E can be uppercase or lowercase. We also have the true and false keywords, which act as the true literal and the false literal. And for the char data type, to have a character literal, you enclose it in single apostrophes, such as the 3 we see in our chart in the single apostrophes. Now, there are 2 other lesser known literals, and that is for the integer data types. For instance, if you precede an integer with 0, so 077, that is octal format. And if you precede the number with 0x, then it is hexadecimal format. Here we have some examples of variable declarations using the primitive data types that we just talked about, as well as the string class. Note, strings are not primitives, they are objects. So in this example, we've declared 2 variables, x and y, of type integer. We've also declared a variable z of type float and set its initial value to 3.414, f. Again, notice the use of the f. Without it, it would have been a double. Next we have the variable w of type double, and we've set its initial value to 3.1415 without the f, which makes it a double. Then we have a variable called truth, which is of type Boolean, and we've set it to the literal true value. Then we've declared a C variable of type char, as well as an str variable of type string, and an str1 variable of type string, which we have initialized to the string by. Then the C variable, we are giving a value of the literal A character. Notice the use of the single apostrophes. And then the str variable, we are assigning it a string value of hi out there. And lastly, we are assigning the X variable a value of 6, which is of type int, and the Y variable a value of 1000, which is also of type int. Now over on the right hand side, we have some illegal assignments. So go ahead and click the first one, the y equals 3.1415926. This is illegal because the y variable is of type integer, and we are trying to assign it a floating point value, which is not correct. Click on the next one, w equals 175,000 with a comma in it. This is illegal because you cannot put commas in your numbers. So this should be 175000 without a comma for the value 175,000. Then click on truth equals 1. Now in C and C++, A Boolean variable can also hold the value 1 and 0, indicating true and false. But in Java, this is not allowed. You must use the keyword true for true and the keyword false for false. And lastly, click on the z equals 3.14156. Now what's wrong with this? Z has been declared as a float, and it looks like a floating point number is being assigned to it. But the problem is that 3.14156 is a literal double, and this literal double is too big to fit into the z variable, which is of type float. Remember, the double has 8 bytes of memory, the float has 4 bytes of memory. We'll learn more about this when we talk about casting. Now, when you create a variable of a primitive data type, such as int, the value that you assigned the variable is copied into that variable. This is not the same way that variables of reference types work. That is, object variables. So let's see how object variables work. So for instance, here we have a myDate class. And on the right hand side, we have a small test program called testMyDate, which is going to create an object of myDate and assign it to the myBirth variable of type myDate. So when we look at this, what we see is that the myBirth variable will be allocated in stack memory, and this is an object reference variable, which means it can hold a reference to a Java object. It does not hold the object itself. A reference is like an address. It's a way to communicate with the object. And what we can do with a reference to an object is access that object's attributes and methods. So the myBirth variable will be allocated in stack memory to hold a reference to an object. Then the new operator is used to create a myDate object. The myDate object will be allocated in heap memory. Heap memory is like long-term memory, where stack memory is short-term memory. So the myDate object gets allocated in heap memory, and then the new operator returns as its return value the address or the reference to the object. That reference is then stored in the myBirth variable, thus creating a sort of link between the myBirth reference variable and the myDate object itself. Then using this reference variable, we will be able to access the object's attributes and its methods. Alright, let's take another look at how primitive values are stored in memory and how these object references are stored in memory, so that we're very clear on it. Here we have several variables that are getting created. An x and y variable of primitive data type int, and an s and t variable of object reference type myDate. So let's see what happens. When we execute the first line of code, which declares the x variable and gives it a value of 7, the x variable will be allocated in stack memory and the value 7 copied into it. On the next line, we will create the y variable. Again, it will be allocated in stack memory. And the x
module, we're going to delve a little deeper.
Copied into the y variable. So with primitives, we are copying the actual value, and x will have its own copy of 7 and y its own copy of 7. Then on the next line, we are declaring the s variable of type myDate. Remember, this does not create the myDate object, and it does not hold the myDate object. It holds a reference to a myDate object. So the s variable gets allocated in stack memory, and then the new operator creates the date object in heap memory. And once the object is created in heap memory, the new operator returns the address or reference to that object and stores it in the s variable, thus creating a sort of link between the s variable and the object. Then using the s object reference, we can access the object's attributes and its methods. Then on the last line, we are declaring a t variable that is an object reference to a myDate object, just like the s variable. And then we are copying the object reference from the S variable into the T variable. So now the T variable will also refer to the MyDate object that is in heap memory, and also then have this sort of link to that object. So now we could use either the S variable or the T variable to access the MyDate object. It wouldn't matter which one we used, because they both refer to the same object. So now it should be clear that when you declare a variable of a class type, what you are really declaring is a variable that can hold a reference to an object of that type. And those references can be copied around. And you can also have more than one reference to a single object. In many languages, when a value is passed to a method, the value can either be passed by reference or passed by value. But in Java, all arguments are passed by value. It doesn't matter if it's a primitive or an object reference. They're both passed by value. What that means is a copy of the value is made and copied into the argument variable of the method. So for instance, we see in our example here that when we call the changeInt method, we make a copy of the value in the val variable and copy it into the value variable of the changeInt method. The same thing happens when we call the changeObjectRef method. The value that is copied is the object reference value. We copy the reference from the date variable in the main method into the ref variable of the changeObjectRef method. And then inside that method, we change the ref object reference variable to point to a new MyDate object. And this change does not affect the original date variable down in the main method. It still points or refers to the original object. The same thing happens with the changeObjectAttribute method call, which is the last call in the main method. Again, we pass the reference that is stored in the date object to the changeObjectAttribute method, and what happens is a copy of that object reference is copied into the ref variable. And then that ref variable updates the object by calling the setDay function. And since this ref variable and the date variable down in the main method both refer to the same object, the object pointed by date is also changed through this call. So you can see it doesn't matter if we are passing a primitive value or an object reference value into a method. It is always passed by value. You just have to remember what is being passed. In the case of a primitive, the primitive is being passed. In the case of an object reference variable, the object reference is being passed, not the object. Some beginning programmers think that you're actually making a copy of the object or passing the object. That is not the case. The object never moves in memory. In Java, you are allowed to name the arguments to a method, or a constructor, or a local variable, the same as your instance variables, or class variables. The local variables, or argument variables, then take precedence over the instance variables. So let's see what we mean by this. Let's go to the first MyDate constructor and roll over the day, month, and year arguments to that constructor. And you will see the variables associated in the constructor with those arguments. Now roll over the day, month, and year instance variables of the class. And we will see how the variables in the constructors are associated to these variables by using the this reference. The this reference is a reference to the object itself. It's a way for an object to have a reference to its own object. And this is the only way to differentiate a local or argument variable from an instance variable. So if you ever use a local variable or argument variable that has the same name as an instance variable, and you wish to use both of them in your constructor or method, you must differentiate the instance variable by prepending on a this reference to the variable, as we see done here. Without the this reference, the variable would refer to the local variable or the argument variable. This is something that's usually very tricky for beginning programmers. So I recommend not using the same argument or local variable names as your instance variables until you get a better handle on this. Earlier, we discussed the naming rules for naming our identifiers. And I also briefly mentioned some of the conventions associated with identifiers as well. Now remember, the rules must be followed all the time. Otherwise, the compiler will give you an error message. But the conventions are just that. They're conventions used by Java programmers, but the compiler doesn't enforce these. We just sort of have agreed to follow them. And the conventions vary depending on if you're naming a package or a class or an interface or a method, etc. So let's go and look at some of the conventions for some of the different items that you may have to name. First, packages. We haven't talked about packages yet, but when we do, we will use nouns in lowercase, such as shipping.objects. Classes should be nouns in mixed case with the first letter of each word capitalized, such as account book. Interfaces, which we haven't discussed yet, will be named similarly to classes. Methods are your actions, so should be verbs in mixed case with the first letter in lowercase. And then within the method name, capitalize the first letter of each subsequent word. So for instance, balance account has a capital A. Variables should be in mixed case with an initial lowercase letter, and then each subsequent word within the variable name can have an initial capital letter. Limit the use of underscores and try to avoid using dollar signs. Constants should be in all uppercase letters, and you can use the underscore character to separate words. Next, we have control structures. Now this isn't a naming convention, it's a coding convention. Now control structures are your if statements, your for loops, your while loops. Now these can execute a single statement or a block of statements. You should always use a block to show the beginning and the ending, and not use a single statement. It'll just make your code a little bit clearer. Spacing. You should always have good spacing and indentations. So whenever you're in a code block, try to indent the code over a couple of spaces to show that you're within a code block. And then any nested code blocks would also be further indented. And then comments. Use good comments. Remember, we already talked about these. The // for a single line comment, the /* and */ for a multi-line comment, and the /** for a Java dot comment. In this module, we covered a wide range of topics. For instance, we learned how to put comments in our source program. We also learned the rules for creating a valid identifier, as well as the 8 Java primitive data types. We also covered the difference between a primitive variable and a reference variable, and how reference variables are used with objects. We also learned how to create an object using the new operator, and how arguments are passed by value in a Java program. We covered these and many other things in this module.